Okay, so we're going to start with 4.5, proving quadrilateral properties. So, system of geometry knowledge. We've talked about theorems and postulates and definitions, and we can use these for building our system of geometry knowledge. So now, we're going to review some of our quadrilateral theorems. So if we look at the first one, we know that a diagonal of a parallelogram divides a parallelogram into two congruent triangles. So two congruent triangles. So it cuts it in half. It breaks into two congruent triangles. What we know is that, well, with this one we have 60, 40. So this angle up here has to be 80. So it has that up to be 180. And we know that these two are the same. So 60 and 60. Angle Q is 60 degrees. We know that angle SPR is 80 degrees. We know that angle RPQ, well, we know that consecutive angles are 180 degrees. So when we add these two together, it has to be 180. So 60 plus 80 is 140. So we know that this has to be 40 degrees. So RPQ is 40 degrees. And then PRQ has to be 80. We add them all up, has to be 180. So this is 80 degrees. When we look at this, we can make our proof here. Our theorem is opposite sides of a parallelogram are congruent. So we can show that the opposite sides are congruent. So we're given a parallelogram, so we can state our statements. We have our parallelogram, A, B, C, D, with diagonal BD. Our reason, it's given. Now what we know about this is that, well, we have a parallelogram, so we know that AB is parallel to DC. So this is our definition of a parallelogram. Then we also know that angle ABD is congruent to angle CDB, and angle ADB is congruent to angle DBC. So these angles are congruent, and these angles are congruent. These are alternate interior angles. So that's our alternate interior angle theorem. So we have two parallel lines cut by a transversal. The alternate interior angles are congruent. So if they're congruent, we know that DB is congruent to DB. That's our reflexive property. So once we know that triangle ADB, so triangle ADB is congruent to triangle CBD, side angle side, or sorry, angle side angle. So we have an angle, we have the side there, and then we have the angle. So if we have that, then we know that AB is congruent to CD, and AD is congruent to CB. These are all congruent because of CPCTC. Our next theorem, opposite angles of a parallelogram are congruent. So the opposite angles are congruent. So we're going to first write our given statement down. I'm just going to save time here and put it here. So our given parallelogram ABCD with diagonals BD and AC, that's given. The next thing we can say is that AB is congruent to DC, and AD is congruent to BC. So we're saying that these opposite sides are congruent. That's our definition of a parallelogram. We can say that BD is congruent to BD, and AC is congruent to AC. So they are the diagonals, but that's our reflexive property. So now when we look at it, we have our triangle. So we can say that triangle ACD is congruent to triangle CAB. Oops, it's a triangle. To CAB. So triangle ACD, that's this triangle right here, is congruent to this triangle right here. So that's congruent to that triangle. And we can also say that triangle ADB is congruent to triangle CBD. So triangle ADB, so that's that triangle, is congruent to this triangle. So the property we're using with these is side, 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 because we have all three of those sides. So we have the outsides, and then the diagonals are congruent to themselves. So we have side, side, side. So that means that angle BAD, so angle BAD is congruent to angle DCB, and angle ABC is congruent to angle CDA. The reason, CP, CTC, corresponding parts of the congruent triangle, are congruent. So all those angles are congruent to each other. Since we showed that those two triangles are congruent, well, technically all four of those triangles are congruent, so the sides or the angles are also congruent. With the back, the first one, consecutive angles of a parallelogram are 180 degrees. I want you to come up with an illustration for this, and we're going to go over that tomorrow. With this theorem, the diagonals of a parallelogram blank. Alright, look at the proof here and figure all that out. So going through, it gives you all the steps. You just have to fill in the blanks. We'll go over these answers tomorrow, and then we can quickly go through these. Alright, so a rhombus is a parallelogram. Remember, it goes up that flow chart. A rectangle is a parallelogram. The diagonals of a rhombus are, the diagonals here are perpendicular. The diagonals of a rectangle are, these are congruent. So you need to know the difference between these two. The diagonals of a kite, these diagonals are perpendicular. A square is a rectangle, and a square is also a rhombus. So a square is both a rectangle and a rhombus, which means a square is also a parallelogram. The diagonals of a square are congruent and are the perpendicular bisectors of each other. So just like the diagonals of a rectangle are congruent, well, these have to be congruent, and the rhombus are perpendicular, so these have to be perpendicular also. So these are some of the theorems that we talked about back in Unit 3 that we just have to remember. And then there's 4 more questions, so just using these properties, trying to figure them out. And we will go over those last 4 questions in class tomorrow. So we'll go over these 4 questions in class tomorrow too. Alright, and that is just 4.5, some proving quadrilateral properties.